My name is Flash Isaac and I'm a teacher from the future. In this episode, we shall be looking at pressure. JAMB expects you to know pressure in liquids, atmospheric pressure, and pressure in solids. Pressure is something that occurs in the three states of matter: solid, liquid, and gases. Gas pressure is explained or taught under gas law. For example, the volume of a given mass of gas is inversely proportional to its pressure, provided temperature is constant. As pressure increases, the volume will reduce. As pressure reduces, the volume will increase. And the reason for pressure in gases is that gas molecules are constantly moving, colliding with themselves on the wall of the container. Pressure is force per unit area. Pressure is equals force acting perpendicularly over area. So pressure is force over area. From this, you can see that pressure is directly proportional to force. Pressure varies directly as force. And from here, you see that pressure varies inversely as area. As force increases, pressure will go up. As area increases, pressure will reduce. As area reduces, pressure will increase. Take a look at it this way. As you are standing now, your body is exerting pressure on the ground. There is pressure. If you are sleeping, there is pressure. You will not notice much of this pressure until you start to stand on your toe like this. Now, like this, you can barely stand for like 5-6 minutes. But standing like this, you can stand for some hours. Then while you are sleeping, you can sleep for days, right? Why so? This is because when you are standing on your toe, the area is very, very small and you are exerting the same force. So pressure becomes so high. If you are standing, at least the area is bigger than when you are standing on your toe. So the pressure is high, but not as high as when you are standing on your toe. As you are lying down, you see that a large area of your body is on the ground. So the area is so big that the pressure is lower. That is the concept of pressure in solids. While I was explaining stress and strain, I said that stress is force per unit area. Now, I am also saying that pressure is force over area. Although pressure and stress have similar definition, although pressure and stress have the same unit, yet they are different. Pressure is force acting perpendicularly. Meanwhile, stress is a distorting force. Stress causes distortion, change in size and shape of object. If the force is acting to change size or to change the shape of the object, that particular force over area is referred to as stress. Now, for liquids, pressure is rho GH. What is rho GH? Rho, this is density, this is acceleration due to gravity, and this is height. From this formula for pressure in liquids, we can see that rho GH. We can see that pressure increases with density. As density increases, pressure will increase. We can also see that pressure increases with height. The more the height, the more the pressure. If you have something like this, a liquid like this, the deeper, the more the depth, the more the pressure. Which means pressure here is different from the pressure here in the same liquids. Pressure increases with height. Now, pressure is the same at the same level and at any point. What this is trying to say is that if you have a liquid here, at this level, at this point, the pressure here is the same thing as the pressure in B, is the same thing as the pressure in C, is the same thing as the pressure in D, so long they are the same height. So the pressure is the same at the same level and at any point. So at any point here, the pressure will be exactly the same. And pressure is exerted equally in all directions. If you have here, if this is exerting pressure here, in all the direction like this, pressure is exerted equally. In all directions in liquids, pressure is exerted equally. And finally, heights of different liquids or heights in different liquid can be found from the formula. If you have two liquids, the pressure of the first one is rho gh, the pressure of the second one is rho gh. So pressure is like constant. When you equate both of them, the pressure of the first one, rho gh, is equals the pressure of the second one, rho gh. H, G and G are the same, so this cancels this. Rho 1 H1 is equals P2 H2. So if you have different liquids or two different liquids and you are comparing their pressure, this is the formula. If you know the pressure of the first one and the height of the first one and the height of the second one, you can look for the pressure of the second liquid. So this is a formula for comparing pressure in different liquids. The unit of pressure natively is Newton per meter squared. Force in Newton, area in meter squared. And Newton per meter squared is the same thing as Pascal. This is the conversion for pressure. 1 atmosphere is equals 760 millimeter mercury, mmHg, and this is equals 101,325 Pascal. This takes us to the Pascal's principle. Pascal's principle states that pressure in liquids is exerted equally at every point. Force is equals pressure times area. If you have something like this, there is fluid here, this is B. If you apply a force here, the force is exerted equally at every point of this liquid. The force applied here can make here to go up. And Pascal's principle has various applications. But this time around, we are looking at atmospheric pressure. What is atmospheric pressure? Atmospheric pressure is simply the air pressure on any object in contact. Any object in contact with air or with the atmosphere gets certain pressure on it. For example, if you look at a can or a plastic, once air is removed from it, you see that it will collapse, quack, goes down like this. That shows that there is pressure or air pressure sustaining that stuff. That is one evidence of air pressure. In your aeroplane, as aeroplane flies, you see that there is pressure of air. It creates certain air pressure, or pressure of air is acting on it, or air exerts pressure on that aeroplane. That is another perfect example of atmospheric pressure. Driving of sailing boats, rotation of objects by wind, and nose bleeding at certain height are evidence of atmospheric pressure. Now, absolute pressure is equals gauge pressure plus atmospheric pressure, or we say plus or minus atmospheric pressure. What is absolute pressure and what is gauge pressure, or what is atmospheric pressure? Before then, P, absolute pressure, can be equals atmospheric pressure plus or minus rho gh, which is the gauge pressure. Gauge pressure is the pressure measured or detected by pressure measuring instruments. If you have instruments for measuring pressure, barometer and other instruments, which shall be explained very soon, the pressure that they detect, that is the gauge pressure. And if you have something like this, here is absolute pressure from here to here. Here is atmospheric pressure, and here is gauge pressure. This implies that absolute pressure is gauge pressure plus atmospheric pressure. Absolute pressure is the total pressure on a body, total pressure acting on an object, and it is a combination of the gauge pressure and atmospheric pressure. And I already said that atmospheric pressure is the pressure air exerts on objects it comes in contact with. The only pressure acting on the surface of any liquid is atmospheric pressure. If you are given a liquid and you are asked to look for pressure on the surface of that liquid, you are indirectly being asked to look for the atmospheric pressure. And gauge pressure is the pressure measured by a pressure reading instrument. It is the pressure of some system above the atmosphere or above atmospheric pressure. Gauge pressure is absolute pressure minus atmospheric pressure. And absolute pressure is the pressure measured with absolute zero taken as reference. Pascal's principle states that the external static pressure applied to a confined liquid is distributed or transmitted evenly throughout the liquid in all directions. If you have something like this, closed, and you have liquid here, if here is A and here is B, if you apply pressure on A, it is applied evenly in all directions. Once you push here, here will also go up. If you push here, here will also go down. This is why the Pascal's principle finds application in hydraulic systems, which is an enclosed fluid used to exert forces. Example, car brakes. The Pascal's principle states that the static pressure acts at right angle to any surface in contact with the fluid. And pressure measuring devices are 1. Barometer. The barometer is used to measure the atmospheric pressure. We have the manometer. Manometer is used for measuring gas pressure, and it operates based on the fact that pressure at the same level in liquids are equal. And we have simple mercury barometer, 14 barometer, and aneroid barometer or altimeter. The aneroid barometer or altimeter is a pressure measuring device that does not have liquid in it. It doesn't use liquid. While simple mercury barometer uses mercury, and mercury is dense. And remember, pressure increases with density. So the rise in liquid in mercury won't be so obvious. This is why we can use mercury as a pressure measuring instrument. The characteristics of simple mercury barometer are: a vacuum exists above the mercury in the tube. If the simple mercury barometer is not 40, a vacuum will exist above the mercury in the tube. If it is 40, air will exist in that space instead of vacuum. A concave meniscus of water in the glass tube. The atmospheric pressure supports a column of mercury. The height of the tube will not be the same if another liquid is used instead of mercury. And the adhesion between water and glass is greater than the cohesion between water molecules. Adhesion is the force of attraction between two molecules. Like water and glass are two molecules. The force of attraction between water and glass is greater than cohesion between water molecules. Cohesion is the force of attraction between molecules of the same substance. So, force of attraction between water and water molecule is lesser than the force of attraction between water itself and the glass. This is why it is very easy for water to wet glass. But for mercury, the cohesion or the cohesive force is more than the adhesive force. The force of attraction between the molecules of mercury is very strong. This is why it is hard for it to wet glass. Its cohesion is greater than adhesion. And the applications of atmospheric pressure are: 1. In mechanical pumps. In mechanical pumps, we have basically 4 types of mechanical pumps, so long this class is concerned. The first one is vacuum pump. Vacuum pump. The vacuum pump is used for evacuating air, to remove air from a space or from objects so that it becomes a vacuum. We have compression pump. This is the opposite of vacuum pump. The compression pump is used for forcing air into an object or a body. For example, the bicycle pump, the tire pump. You are pumping air into the tire. That is a compression pump. We have the lift pump. The lift pump is for raising water or pumping water up to a height lesser than 10 meters, while the force pump, which is the fourth pump, is used for raising water above 10 meters height. Drinking with straw is an application of atmospheric pressure. Hers apparatus is used for comparing density of liquids. So Hers apparatus is an application of atmospheric pressure. And pressure measuring devices generally are applications of atmospheric pressure. Now let's look at these questions under pressure. This question says, a stylus of a phonograph record exerts a force is equals 7.7 times 10 to the power of minus 2 Newton on a groove of radius r is equals 10 to the power of minus 5. Compute the pressure exerted by the stylus on the groove. This is the force, and we are given the radius to be 10 raised to the power of minus 5 meter. What is pressure? Pressure in solid, P is equals force acting perpendicularly or normal force over area. This is the same thing as weight over area, because the normal force is equals weight. Action and reaction are opposite. As weight is acting downward, there is a force that is opposing the weight. That is the normal force. From here, what is area? We don't have area, but we have radius. From radius, we can calculate area. Area is equals pi r squared. So pressure is equals 7.7 times 10 to the power of minus 2 over pi times 10 to the power of minus 5 squared. That is it. That should give you 2.45 times 10 raised to the power of 8 Newton per meter squared. Option A is correct. At what depth below the sea level would one experience a change of pressure equal to 1 atmosphere? We are looking for height, and we know that pressure is equals rho GH. So at what depth will one experience a pressure that is equals 1 atmosphere? What do we do? From here, we have the atmospheric pressure to be 1.01 times 10 to the power of 5. This is equals, the density of water is 1013. Gravity is 10 times height. The height is exactly what we are looking for. Since we have the atmospheric pressure, we have the density of seawater, and we have acceleration due to gravity. Height therefore becomes 1.01 times 10 to the power of 5 over 1013, let me see, times 10. That is your answer. This should be equals 10 meters. So if you have the atmospheric pressure, you have acceleration due to gravity, and you have density, and to look for height. In this case, height is equals 10 meters. And the next question, Roman figure 1, density of the fluid. Roman figure 2, depth below the surface of the liquid. Roman figure 3, surface area of the liquid. In which of the statements above will pressure be dependent? What does pressure depend on? Does pressure depend on density? Yes. For liquid, pressure is rho GH. Pressure depends on density. Pressure depends on height, which is the depth below the surface of the liquid. So depth below the surface of the liquid is what density, pressure depends on. Area of the liquid, no. When it comes to solid pressure or solids, pressure depends on force and area. But for liquid, area, pressure does not depend on area when it comes to liquid. So I and II are correct. That is option C. A man exerts a pressure of 2.8 times 10 raised to the power of 3 on the ground and has 4 times 10 raised to the power of minus 2 meters squared on his feet in contact with the ground. The weight of the man is dash. Since the man is having a contact with the ground, weight is equals force. So pressure is equals weight over area instead of force over area. Weight becomes pressure times area. What is pressure? 2.8 times 10 raised to the power of 3. What is area? 4 times 10 raised to the power of minus 2. When you multiply them, you should be able to arrive at 112 Newton. So that is the pressure as seen in option A. And the next question, determine the pressure at the bottom of an ocean 8 meters. The depth of the ocean is 8 meters. If the atmospheric pressure due to water is, so PATM is equals 1.2 times 10 raised to the power of 6 Newton per meter. The density of water is 1000 kilogram per meter cube. So density of water 1000 per meter cube. And acceleration due to gravity G is equals 10 meters per second square. These are the values that we are given. Now look at this. Anytime you are given ocean, river or well, the total pressure at the bottom is the sum of atmospheric pressure and the pressure of the liquid. So the total pressure is equals atmospheric pressure plus the pressure of the liquid, which is rho GH. This is the formula when you have well, sea or river and you are asked to look for the pressure at a particular depth or bottom. You say it is atmospheric pressure plus pressure due to the liquid or due to water. The pressure becomes atmospheric pressure 1.2 times 10 to the power of 6 plus pressure due to water is 1000 times 10 times 8, which is the height. So when you multiply this, you should get 1.28 times 10 raised to the power of 6 as seen in option D. Thanks for watching your one and only teacher from the future. I hope you found this class interesting. Feel free to check out the playlist for more amazing videos, and don't fail to install the Flash Learners application right now for notes, videos and questions to meet all your needs. Subscribe to this channel so you don't miss out any of my sweet videos. See you in the next episode. Don't forget to tell everyone around about the Flash Learners. Bye.